Using properties of determinants in the following show that the value of determinant is 1 plus a square whole cube. Let me tell you that this question was asked in CBSE 2008, that is last year exam, for 6 marks. Now how to do it? You have to look at it very carefully. The first step is very important, that at least you get 1 plus a square plus b square common. So if you look at it carefully, here in the first, let me write the question, the left hand side again. You get the value of determinant equal to 1 plus a square minus b square, 2ab, 2b square, 2ab, 1 minus a square plus b square, minus 2a, and minus 2b, 2a, and 1 minus a square minus b square. Now, if in column 1 you subtract, see, because if you multiply this 2b by b square, b, it becomes 2b square added to this term will make it plus properties prove that the value is already negative. So multiply by negative. So the first step is replace C1 by C1 minus B times C3. Using properties prove that the value of the determinant is equal to A plus B plus C whole by C2 plus determinant is given as A times the elements of C3. The first. See what will happen, A times C3. So C1 to be replaced by C1 minus B times C3 and C2 by C2 plus A times C3. What do you get? So in any case, C3 remains unchanged. So now C1, first term is 1 plus A square minus B square multiplied by, this term, minus 2B into minus B will make it plus 2B square. Added will make it 1 minus A square. Let me take then one more step. 1 plus A square minus B square and minus B times minus 2B, so plus 2B square. And likewise here you will get 2AB minus 2AB, and in the last you have 2AB minus B times 1 minus A square minus B square. And in C2 you add, as I said, A times C3, so you have 2AB minus 2AB and 1 minus A square plus B square plus 2A square, and the third element in second column is minus 2A plus A minus A cube minus AB square. This is minus out here. In the last column, third column, you already have minus 2B, 2A and 1 minus A square minus B square. And just work it out. So you have 1 plus A square minus B square and 2B square will make it 1 plus A square plus B square. 2AB minus 2AB is 0. And now just be careful. 2B, just look at this term, I'll show you here. 2B minus B and minus plus BA square and plus B cube. So here 2B minus B gives you B. And now if you take B common, please try yourself in rough, you are left with B plus BA square plus B cube. If you take B common here, then of course you will get 1 plus A square plus B square, or you may take one extra step. Now in the second column, 2AB minus 2AB cancels to give you 0, and 1 minus A square plus B square plus 2A square, so we'll make it 1 plus A square plus B square. And in the last term, minus 2A plus A is minus A, so if you take minus A common, you will left with 1 plus A square plus B square. That you will get. And the third column, that is minus 2B, 2A and 1 minus A square minus B square will remain the same. And clearly, now we can take 1 plus a square plus b square common from C1 and also from C2. So taking common 1 plus a square plus b square from C1 as well as from C2. So you will get outside 1 plus a square plus b square whole square. And then you left with, inside you left with 1, 0, b. In the second column you get 0, 1 minus a, and third column of course remain the same. That is minus 2b, 2a, and 1 minus a square minus b square. What do you do now? See, in R3, if you subtract b times R1, so b minus b will give you 0. So at least 2 zeros will be there in C1. So let us apply change R3 by R3 minus b times R1. That is, to R1 you multiply by minus b and add to R3. 1 plus a square plus b square whole square is already outside. Keeping, R1 and R2 the same. R1 is 1, 0, minus 2b, and R2 is 0, 1, and 2a. Now in R3 what are you doing? You are subtracting from R3 minus b times R1. So b minus b will make it 0. And of course this minus a will remain the same because you are adding 0 times b. And to the third element, when you are adding multiplying minus b with minus 2b will make it plus 2b square. So 1 minus a square minus b square and plus 2b square will make it what? If I write it here only, this element can be simplified to 1 minus a square plus b square. Okay. So now the next step, you already have 1 plus a square plus b square whole square outside, and inside the determinant, if I just rewrite it again, you get 1, 0 minus 2b and 0, 1, 2a and 0 minus a, 1 minus a square plus b square, just to show you clearly. And now obviously we can expand along C1. So expand along C1. 1 plus a square plus b square whole square is already there. Expanding with C1, you get 1 time 1 into 1 minus a square minus b square. So you get 1 minus a square plus b square and minus plus a into 2a square. So you get 1 plus a square plus b square whole square, and here you get 1 minus a square plus 2a square, so that will also be 1 plus a square plus b square, and obviously you get now the required result, a 1 plus a square plus b square whole cube, and that is your required right hand side.